Okay. Hello guys. Today we're going to work a bit more on type functions. Let me get my terminal up. Then we go to here where we have the alias table, and right now the type function functionality is hidden behind a switch which disable it. So you will see that you cannot pass type serialized as tag, or this is a type, to a function inside this test alias struct here. But inside this type function here, you get the alias array. So the only switch that the type function switch controls is whether this gets passed or not. So we pass the switch SKTF and we run it, and then we see test alias struct has no return statements, but is expected to return something. Right, this, and then we do this. We do not need for each them because there is no need to do that, and we get out a result which is a type function. So let me change the size of this this as a type struct by putting a double in there. It's called double y, and then we run this, and we see that the size here changed, which tells us that when we pass a type with name into type with name and size, we can still get out the correct type, and we can get the size of that. So that is good. That is something that you wouldn't be able to do with templates without going through gyrations. Let's give ourselves another tag. Let's call it the super tag, and let's attach that to this type here, super tag. And why don't we give this super tag a string, string y, string s, and we give the super tag with hello or super. Yeah, let's do super exclamation point, and then we look at this again, and we still see this is a type with this as a type, because we don't look at what comes back from a type with tags. Now we do that again. Where? Now we look again at what comes back from type with tags, and what we get out is we get the serialized tag and the super tag with the super in it. So what we can do now is we can go through all of them for each tag and tags, and we can do tags concatenate equals no, we don't do that. What I can do is, if tag equals serialize tag, we break it. So when we visit the second tag, we break this one, and equals cannot be used with types. So that means we gotta use an is expression here, and that would work if let's make another do like that. Let's say we want to filter the UDAs. We go through all of them. If it's a serialized tag, filter UDAs, and it equals. Okay. Now, it says basic type expected, and that's because alias array cannot be passed, so we have to do alias array, which is the type you need for an alias of that. And then we go on about this. We have an undefined identifier in line 27. That's most likely because we just wanted to say that, and we say, and it says cannot append string to type alias. That's because that iterates the text, which is not address attributes. So we want to go through the UDAs. I'll do UDA. That's what I'm going to do. And it says cannot cast serialized tag to alias at compile time. That means we need to implement this cast. Just to be sure, a cast to alias always succeeds, as long as it's not a literal. Like, a cast to alias of the string hello by itself wouldn't work, but a serialized tag can be cast to alias. There's no problem with that. So we should make it such that that works. And then we'll see something else that's surprising, because at least on this branch of the type functions, we do not deal with is expressions, since that is expression handling will maybe require scope, though it may be possible to make it such that it doesn't, and that is what we'll try right now. Doing first the cast to alias, and after that the is expression. So let's look at the alias patch. Cast. We have change in CTV cast that shows how I implemented the cast to alias. And we have one, and I want to say that we have one in here. That one is for get variable, I assume. We had one for casts, for the cast exp. And for the cast exp, all we do is if it's a cast to alias and it's not a variable, we just strip the cast to alias a y and leave the thing that's behind there, because cast to alias is essentially a no-op. So that's what we'll do right now. We go into the deinterpretee, which is here. We go to cast exp. There we go. And there we have the we already have that in cast exp e. So if that's the case, from where do we get that then? It says cannot cast. It's not here. It might be in CTV expert here. Could that be? Yes. Okay. That means we need to do a change in CTV cast, in which we do pretty much the same, I would think. I would think, what was it? In here. I mean, wait, I can see if that changes anything. And what we did here is we also added this one. Right. So yeah, that is because this. That could probably already do what we needed to do, though it may not. Oh no! I know this did it, because basically those are already aliases. So what we just did was to make this appending here work. Okay, so now let's look at the filtered UDAs. And that should only include serialized tag, because it only allows this tag if it is the serialized tag. And what we'll see here is null. And why is that? That's because the is expression is not evaluated during CTV. The is expression is evaluated before CTV. It looks at tag, and that tag is not the same as serialized tag. Actually, how can it even look at tag? Tag is not even a name that's in there. And the reason it can do that is because the errors for is expressions are gagged, which means the fact that this expression inside of here does not even compile means it will just be false because it becomes the error. If we change that to UDA, we still don't get anything out because UDA is of type alias. So what we have to do here, and by the way, we can comment out this if, and then we should get both UDAs again. And you can see that that's the case. So that's an interesting one. Haven't had that before. It turns out that the first UDA in here is UDA, and the first UDA gets made into an alias and the second one doesn't. No, it might be that's because one is an empty struct and therefore just a type, and the other one is a type, a literal. So if I put in another super tag and call it SSS or smoking super style, let's see if we see that. So we do see super and we do see smoker super style. Smoking super style. We will presumably also see that if we put that into the first position. And yes, we do see supertext, smoking super style, alias, and supertext super. So that means that the problem is with the serialized tag being a mere alias inside here. So just to make sure that that doesn't happen if we pass the UDAs through, just say UDAs, just like that, and now we should see all the tags just as they are, and yes, we see the super tag, which is a literal and not a type. We see the serialized tag, which is a type, and the supertext super, which is not a type again. That is a literal, it's not a type. Okay. Now, I think we want to solve this problem first. Maybe. Or maybe, which... Yes, we want to solve this one first. Because this one basically includes the one that we'll have with the is expression, which is that the is expression will return 0, will return false because there's no serialized tag coming through here. It's just an alias. Want to do this. There we go. Okay. So, what we want to see is the filtered UDIs being the same as the unfiltered UDIs. And that means something inside of what this for each becomes has to be responsible. Let's have a quick look at that. Okay. Now this should have generated a file which shows us the rewritten AST. And here you can see what the for each becomes. Right? It becomes this for loop. Which of course is a bit unfortunate because we copy the whole array into another local. We do not need to do this. This can just be UDAs. And then we can get rid of this local. This can be UDAs. And it can even be different because this length won't change while we are running a for loop over it. So this would just be len. And then we would store the length. Here. So that is an optimization. Key 3, we can keep the way it is, or we can just call it IDX. It doesn't really matter. Maybe we want to call it IDX to make sure we know what it is. There we go. So this shows us the way that this is written, right? And then, I mean, we still have the problem. This didn't change anything because why would it? We kept it as it is, pretty much. Now this shouldn't have changed. Oh, I see. Yeah. The reason this changed is because we didn't save the version we wanted. So again, we want to have a constant length. Then we can use that in here. The compiler now knows that it won't change. One reason why you usually don't get loop unrolling with for each loops is that because of that copy and such, compilers have a hard time tracing that the change should be happening. And I guess we just want to copy that out, because this thing, this tuple that we see here, that won't compile. That's just for certain. So that's weird. We have a tuple with the super smoking style and the serialized tag together, and then we have another tuple with just the super tag and the ed. This seems quite weird to me. I am actually not quite sure what's going on here. We shouldn't have a tuple nested in a tuple, and we don't. But why do we form two different tuples inside a user-defined attribute list? That doesn't make sense to me necessarily, but it doesn't have to. I can just rename this. And then I should not forget to copy it. That was interesting nonetheless, because I didn't know that happened. So we go to here into the source, we comment this out, and we just have to replace this by UDAs and this by IDX, and then we have a bit more of a direct access. We don't have a copy of the alias array, and that might make a difference. It doesn't, because this has to be alias array or auto, and this has to be alias array. So now that's that. Identifier key 3. That becomes IDX. And now, alias UDI cannot alias an expression. Yes, that would be because we didn't use the assignable form of alias. So this is not the form of alias variable, right? This is the form of alias variable. We cannot declare the alias and assign at the same time. Okay. Apparently it doesn't like us writing this in here. I mean, we don't have to, we can just say UDAs of IDX. We don't have to use this. And yes, even with manually rewriting it, this doesn't work because the alias, which is a type, comes back as an alias, whereas the aliases that are expressions do not come back as alias. Okay? So now what do we do? It's tricky. We need to know where this access happens. And the only way to know where this access happens is to see where those things are created. And the only way to do that is to print the serial numbers, the AST serial numbers, along with the output of pragma message. This shouldn't be too hard, but we should defer this to another video.